Okay, so in this video, I'll be making this actually in three series, three parts. Okay, uh, it's about finding the equation of a hyperplane and then finding the equation of a line in an n-dimensional setup. Okay, so this video is about finding the equation of a hyperplane when we have been. Okay, yeah, let me just do it. Okay, it's already in the title, by the way. So, say say we have been given this. I'll take three-dimensional space as an example to make it easier to understand. Okay, so this is my x-axis, this is my y-axis, and this is my z-axis. Now I have a plane. Okay, so say this is my plane, right? A little bit better. Okay, so this is my plane, right? Now what I have to do is, and I have been given a point. I've been given a point P, any point x, y, z on this plane. Okay, so I have to find the equation of this plane. Now, apart from this, first let us look at the equation of a plane and understand what it represents. Okay, so for this three-dimensional space, the equation of the plane looks something like a1x plus a2y plus a3z equals b. Right? Now here, these x, y, and z, they represent our dimensions, the dimensions of the space. And what this a1, a2, and a3 represent, these are actually the components of a vector. These are the components of a vector u, and what this vector actually is a vector which is perpendicular to the surface of the plane. So this is the u vector, a vector orthogonal to the plane, right? And about this b, let's look at it this way. In our two-dimensional geometry, how do we represent the how do we represent a pair of parallel lines? Okay, they are like this, like ax plus by equals c1, and then ax plus by equals c2. Right? This is how parallel lines are expressed. Right? So this is same. Okay, and these differ. Right? So similarly, the same is the function of b here. Okay, so if we were to find a plane parallel to this, then all of these values will remain the same, and the thing that will change will be the b1, the value of b. It will change. Okay, now this is three dimensions. What if we had n-dimensional space? How would the equation of a plane in n-dimensional space look like? So it will be like a1 x1. Now see, for n dimensions we will take x1 x2 because we don't know the value of n, so it can go to like any value, any required value. X, Y, Z are alphabets. We can just take 26 of them. Okay, so a1 x1 plus a2 x2 plus so on goes on till an xn for our n-dimensional space, and then this is equal to b. Okay, and it's just an extension of this equation, right? So now let's try to find an actual equation. Okay, for that, let's say we have the point. Let's say we have this point as 1, 2, 3. Okay, pretty basic. And let's say that our vector u is the vector which is perpendicular to the plane of which they are asking us to find the equation. That is u, right? So let's say the vector u is -2, 0, and 3. Okay. So, and I hope you understand the difference between, yeah, this is basically representing -2 I cap plus 0 j cap plus 3 k cap. This is the vector, okay? Right? Now, this is a three-dimensional space. So our equation should look like a1x plus a2y plus a3z equals b, right? Now, this x, y, and z, they just represent any point on the plane. And here we have a point on the plane. So I'll plug in the values of 1, 2, and 3 here, right? And then this a1, a2, and a3. This is my a1, this is my a2, and this is my a3, right? So I'll just plug in these values. Okay, so what I get is -2 times 1 plus 0 times 2 plus 3 times 3 equals b. Okay, so now I get as -2 plus 0 plus 9 equals b. So the value of b comes out to be 7. And hence, now this was for a particular point. We have n number of points on the plane, right? So our general equation for this will be -2 times x plus, now our y component is 0, so I'll skip it, and 3 times z is equal to 7, right? So this is the equation of the plane which is passing through this point and which has this vector perpendicular to its surface.